All right, guys. Hope you can hear me, and I hope you heard that nice little music intro by our friends from Storm Weather Shanty Choir. Somebody just say yes if you can hear us, and make sure this is all working on the chat, please. Cool. Emma said fun tunes. Awesome. So welcome, guys. We're going to talk about offshore weather fundamentals today. I am Andy Schell, your host, and I've got my two co-hosts here with me, Ryan Finstad on, I think there he is. Wave, Ryan. Ryan's broadcasting from California. Is that right?
Yep, San Diego.
Cool. And, of course, ICEBEAR skipper August Sandberg from Bergen, Norway. Ahoy, August.
Ahoy.
Cool. So I'm going to give you guys a quick rundown on how this is going to work, and then we're going to jump right into it because we've got a lot to cover today. Ryan is actually here. He's going to sort of moderate the chat today. So Ryan's going to diminish his video screen to save on bandwidth here, and you're just going to see August and I for most of this. There's going to be a lot of screen sharing, so I can show you guys some visuals on the screen. So when we do the screen sharing, we'll take the video away as well so that it saves on bandwidth again. This is going to be a lot of fun, and this is the first of these live streams we're going to do. Hope to do a lot of these, so this is going to be really cool. A quick sort of reminder, we are doing this for fun and for free, but if you guys think that you got something valuable out of this and have a little extra disposable income despite the quarantine, we'd love if you chipped in a little bit and send us some quarantine beer money. And you can do that at the bottom of the screen. There's a button that says donate. I'll have Ryan send a prompt out at the end of this as well. So that would be great. Eventually, like I said last week, we may end up starting to charge for these seminars if we think that we can create enough value. But for now, they're free. But if you think they're worth something, send us some cash money. Another caveat, or first caveat, I have to note that we are not meteorologists. So when I talk about weather here, this is my disclaimer. I'm not a meteorologist, but we do a lot of weather research when we do our offshore passages, and we have a pretty firm grasp on what tools are available and how to use those. One of the things I'm going to talk about and emphasize today is the idea of uncertainty. Weather forecast is simply another form of predicting the future, and predicting the future is really hard. So we're going to talk a lot about uncertainty and how that goes into making decisions when we're talking about offshore weather. We're going to talk about how large-scale weather forces drive local conditions. So it's like see the forest for the you can't see the forest for the trees. If you're zoomed in too low, you don't know why that you're getting the wind that you're getting. We're going to talk about factors that can change how you look at a forecast, like if you're in the Gulf Stream. And we're going to focus on the North Atlantic because that's sort of our backyard, our playground, where we spent most of the last 5 to 10 years sailing back and forth everywhere from as far south as Grenada, which I think is about 10 degrees north latitude, up to where I met August 2 years ago now, up in the Arctic at
That's
80
right.
degrees. Hence my my tattoo on my shoulder there to prove it.
Yeah.
So like I said, what my goal is for this here is I hope that you're going to leave here simultaneously with a better understanding of how to evaluate and predict weather, but almost more importantly, how to properly respect the fact that predicting the future is really hard, and that uncertainty really needs to affect our decision making accordingly. And August and I were chatting before. This is sort of a high level weather course, so I'm going to make a fair amount of assumptions, and I'm going to breeze through some of the more basic stuff just as a recap. But we're not going to spend a lot of time on really basic how does wind get made, blah blah blah, that stuff. But I will touch on it. So we're going to record this. So if it's a little bit over your head for now, you can go back and watch it later. And this will be good to see if you're going to join us next week when August and I look at the actual passage weather from BVI to Bermuda, which unfortunately we're not actually going to be sailing right now, August. We're stuck in our houses in quarantine.
Yeah, it's too bad. This is fun too, though. I like this. Let's do as much as we can. So
this is cool. This is cool. All right, Ryan, if you want to set aside your video and stay on there, I will also mention you guys can ask questions right now. If you have a serious question you want us to answer, use the Ask a Question feature at the bottom of the screen. That way it can get upvoted by your the other audience members, and we'll take not just the most popular questions, but the ones that we feel like we can answer the best. So we'll do that throughout the seminar, and then towards the end, we'll have an open Q&A section for anybody that wants to hang out a little more. I expect this to go about 90 minutes. That's my hope. But I don't have anywhere else to be, neither does August. So if anybody wants to hang out for longer than that, well, let's do it. All right, cool.
We can do some extended question stuff at the end, maybe if people are still hanging around. So
we'll try to keep the content stuff to about 90 minutes. So, all right, let's kick this thing off. August, you and I planned this, and I wrote here, before that we get too pleased with ourselves and thinking we're really smart with weather forecasting, I think we should each start by sharing a story of where we got the weather wrong. And I'm going to let you kick us off here with the fun "we screwed it up" story.
Yeah, I do have a few of those, and I definitely learned weather the hard way. This is the good way of learning about weather. The one that I'm thinking about was in 2012. I was 22 years old. I was the proud skipper of my very own Baltic 37. I was just starting circumnavigation from Norway. And it was going to be the first ocean crossing of the trip, west coast of Norway down to Amsterdam. And we'd been stuck in port for several days, just waiting for a favorable wind to go south. And this tiny, crappy place, it was a fish factory, nothing else, and we were going nuts. And then when that northerlies came, they came with a vengeance. And I remember we were sitting in the harbor, and we were looking with our binoculars. We were looking at this flagpole at this distant sort of cliff out by the ocean, and that was sort of our forecast. And when we saw that flag streaming south, we just went for it. And we had looked at the weather forecast as well. We knew some, and we knew that it was going to be a lot of wind, but we did not appreciate how much it was going to be, and we did not have sort of the understanding of what a lot of wind looks like offshore. And I think the main thing we missed was that the difference between 20 and 30 knots is like nothing compared to the difference between 30 and 40. And we were out there for 3 days going south, and it was some of the roughest weather I've ever seen. Probably for at least a full day of that, we did not see anything below 40 knots on the boat. And we were just racing downwind, surfing down some crazy waves. And our top speed measured by the GPS was 18.8 knots. And that is on a 20, that's a water line of 27 feet. I was at the helm on that and just clapping on and sort of supporting my whole weight on the wheel. The hull was like perpendicular to the. It was
I'll remind everyone that August is the skipper of ICEBEAR, so if you want to come and you're a safety conscious skipper. The thing is, though, the one quick takeaway from that story is, had you been going upwind in those same conditions, you would not have been sailing. You would have been hove to or on a sea anchor or something. And that is something I'm going to touch on today, that when you decide whether it's go or no go, it reminds me of the Moitessier said back in the day, you never waste a fair wind. And you guys, basically, that's what you did. You looked at the flagpole, it was going south, going in the right direction, off we go. And
that's right.
Man, it was downwind and it was gnarly, but you did it. And there is a major difference between heavy weather, depending on what direction the wind is relative to the boat. So that's a good takeaway from that story.
Extremely, absolutely, yeah. We did limp into Holland with like a broken backstay, and we were not in a happy place. So it was, that was not a good thing to do. But I learned a lot, and it's a crazy sea story that hopefully someone else can learn from.
So I have a version myself. I've got many of these, but the one I'm going to share, I actually have a short little video to show you guys. So August, if you want to turn your video off for a second, I'm going to share my screen. Let's see. Okay, guys, I'm going to turn my video off for a second as well and share my screen. And I think you should be able to see a video on the screen. August, can you see this video on the screen? Can you just confirm that?
Yep, I see it.
All right, so what I'm about to show you guys, this was just recently. This was February of 2019. We were going across the Atlantic on ICEBEAR. This was right before we got the new boat ICEBEAR in Antigua. In fact, when we made landfall on this trip, that's where the new boat was waiting for us. So it's Mia and I. That's her butt in the picture right there. And typically, an east to west Atlantic crossing in the trade winds is beautiful downwind sailing. But we wound up in this weird, really strange weather pattern that involved what's called a cutoff low. And I'll save that for later. But the trade winds effectively got disrupted by this low pressure system that was kind of just sitting in the middle of the Atlantic where there's normally a high pressure system. And we had looked at the Gribs that we were getting offshore. And part of what I'm going to talk about later is the limitations in weather data that you can actually get when you're offshore. So we were getting pretty low resolution Grib files, which is a visualization of the weather. And I just misinterpreted it. And had I asked a professional weather router, I could have seen this coming. But what we had was this really weird area of unsettled weather. And we sailed into this squall line. As you can see, our setup here on the boat, we had one reef in the mainsail. And before this squall hit us, we had the Genoa pulled out on the end of the pole, and we were going downwind. But this big cloud line approached, and I was like, let's roll in the jib. We didn't have time to take the pole down. And we were just sailing here in downwind with one reef in the main. I was at the helm, but we had 50 knots of wind at least, because we were sailing, the boat was going 10 knots, and the anemometer on the thing was showing 48, 51. So it was pretty crazy. So here's just a quick little clip that one of our crew members took of what that looked like. And trust me, you never get a sense in a video of what it actually feels like. Thankfully, this only lasted for about 40 minutes, but here you go. And there was nothing we could do. There was so much wind in that mainsail that we couldn't possibly get the mainsail down. August, you can come back up on screen if you want. We couldn't get the mainsail down at all. I'm going to stop sharing my screen when it was that windy. So that was just kind of one of those things. And my point with that is you can only do so much weather forecasting on a long passage like that. You know, we were at sea for 3 weeks, and eventually you're just going to get bowled over sometimes. And because of that, you have to, it's all about preparation. You know, if you're going to actually undertake a real long ocean passage where you're going to be at sea longer than you have a weather window for, it's down to the boat's preparation. And as you can see there, ICEBEAR handled that no problem. The helm never felt out of control. I felt like we had way too much sail up, but there was nothing we could do about it. We just had to ride it out. And that was the end of that. And we didn't break anything. Nothing really happened. So, but that's my, we kind of messed it up weather story for you. August, have you had ICEBEAR yet in any real heavy weather?
Not really. We had, I don't know, like I've never seen 40 knots on the boat at all. We had, when that cold front was passing, when we were at Bermuda, we had maybe 35 for like an hour or so, but yeah, nothing bad at all.
Well, she's a fine sea boat. She'll keep you cozy.
Yeah, I can imagine.
All right, so we're going to start getting into the nitty gritty here, and I'm going to give you guys some what I call big picture weather. This is like what I said before about forest for the trees. I want to show you how weather patterns in the North Atlantic, how they work, how the whole system interacts with itself. And I'm going to start sharing my screen again in a second, and I'll have our videos go away. And then August is going to come in and talk about how those Atlantic weather patterns expand up to Northern Europe, into Norway, and to August's neck of the woods. But we're going to start with the trade winds. So give me a second to take our video off here and share our screen. So August, if you want to reduce your video again. And I'm going to share my entire screen so I can flip around here a little bit. And I'm going to take my video down as well. So you guys should see a full screen there from my screen. And I'm going to go to a website called the Ocean Prediction Center. And if you guys scroll all the way to the top in the chat, there is a link I put with an outline for today's talk that has all these links that I'm going to go to, so you guys can look at these later. But what this is ocean.weather.gov. So this is NOAA's Ocean Prediction Center. It's their meteorologists do this for most of the ocean. August. Never mind. Okay, so this is the homepage for the Ocean Prediction Center in the Atlantic. The next tab here is what's called a synoptic chart. So there's a little bit of interpretation to make here, and I'm going to get to where I said we're going to start with the trade winds, but I want to explain what you're seeing here first. So if you can see my cursor, August, can you see my cursor on the screen here just to make sure everybody's seeing what I'm seeing?
Yeah, it's looking great.
All right. So if we look up in the top left corner, you've got the sort of the key to this, and it says Atlantic Surface Analysis. This was issued at 1439 hours UTC today, and it is valid as of noon today. So this is a real-time picture of what the weather's doing in the North Atlantic. And geographically, we've got Greenland at the top here in the middle. If you go over to the right, you can see the bottom half of Iceland. Keep going further right, you can see the west coast of Norway. Right about there is where August is, somewhere up there on the left. Then we've got UK and Ireland. A little further south, we've got Portugal down here, Straits of Gibraltar, coast of Africa. Moving along the bottom, this is that trade wind belt that I'm going to start talking about in a second. We've got Dominican Republic, Puerto Rico, Cuba, Florida, east coast of the U.S., all the way up to Nova Scotia and Newfoundland. So that gives you a sense of what we're looking at here geographically. What all these symbols and stuff mean, you've got these reddish-orange lines that look like topographic lines on a map. Those are called isoBARs, and they indicate a pressure gradient. So just like if you're looking at a map of a hike or a mountain, the closer those bars are together, the steeper the gradient. And as I mentioned before, wind is created because, generally speaking, air wants to move from high pressure to low pressure. You can think of a low pressure as a valley in a topographic map and a high pressure as a peak. So if I look right here on the tip of Greenland, I've got this L. That's the center of low pressure here. And if I go straight to the right over towards Norway, I've got the center of high pressure here. So if you can visualize that as a three-dimensional mountain, so to speak, the high is the top of the mountain. Then you go downhill gently here where these isobars aren't quite so close together. And then the gradient starts getting steeper. So you're getting steeper, steeper, steeper down into the valley. And now at the center of the low, you're at the bottom. Right here, it tells you you've got 976 millibars. That's just a unit of pressure at the center of the low, up to 1027 at the center of the high over here in Norway. And as I said, the closer those isobars are together, the stronger the wind's going to blow. And as you can see right here, it says in that square, gale. So they're forecasting a gale in that particular quadrant of this greater low pressure area here. These other colored lines, you've got a cold front that comes down off of this center of low that actually connects with another low center down here in the middle of the Atlantic, and as another cold front that extends all the way over to Florida. A cold front is quite simply the boundary between a cold, dry air mass coming down from the north and a warm, moist air mass coming from the ocean on this side. These red sort of half circle lines, that's a warm front or an occluded front if it's combined with a triangle there. And what else can we see on here? You got some wind barbs down here that you typically see on Grib files, which I'm going to show you a little bit later. Those wind barbs indicate which direction the wind is coming from and how strong. So this one here in the center bottom of the screen has a long tick and a short tick that indicates 15 knots blowing from the southwest. So that's a southwesterly wind of 15 knots. And then you can see some terminology here. You got a developing gale over on this quadrant just between Cape Cod and Nova Scotia. Developing storm over here off of this center of the low down south of Newfoundland. And it's April, so there is still an active winter weather pattern in the North Atlantic. You get these strong low pressure systems that come off the continent and can kick up some really gnarly weather as you get further north in the Atlantic here. So it's still pretty early to try to cross the Atlantic or even come north from the Caribbean back to the U.S., so to speak. Let's see here. What else can I show you on this page? That's pretty much all you're seeing here. But again, this is my point with this particular visualization is this is a chart that is created by a human being. And it even tells you that in the top left corner. It says right here, forecaster Nolt. So whether that was a Mr. Nolt or a Mrs. Nolt, it doesn't say, but it tells you who the person was that physically drew this chart. And that is really important when we talk about Grib files. And I'll come back to that. So on the trade wind side of things, stand by a second. Sorry, I got distracted there. On the trade wind side of things, if we look at this overall synoptic chart again, you've got a high pressure system that is in the bottom center of the screen here. And that high, it's sometimes referred to as Azores high in Europe, sometimes referred to as the Bermuda high to us North Americans. But this center of high pressure is more or less stable in the middle of the Atlantic most of the time. And this is what creates the trade winds, because a high pressure system, August, rotates clockwise or counterclockwise?
High pressure rotates clockwise, low pressure counterclockwise.
Correctamundo. That is in the northern hemisphere, and the opposite is true in the southern hemisphere. So
Yes.
what we have here, and I'll come back to the wind thing. Wind travels across isobars. We have this thing called the Coriolis effect, and that's the spinning of the Earth. So if you just imagine for a second that the Earth wasn't actually spinning, wind would travel perpendicular across isobars. You'd have it straight from the high down to the low. But because the Earth is spinning, and actually the spinning of the Earth is kind of what creates weather in the first place, but that's another story. Because the Earth is spinning, the wind tends to want to travel from high to low, but it does so at an angle. So wind will travel from the center of a high pressure out towards a low pressure, and it'll be almost parallel to the isobars. If you look at this high over here by Norway, it's going to want to go, in a vacuum, it would go straight to the low. But because of the spinning of the Earth, it's going to get deflected a little bit. So it doesn't quite follow the isobar exactly, but it's kinked slightly from in to out. So if you look down here at our Atlantic high in the middle, the wind barbs kind of start from the center and go slightly out, but more or less follow the isobars around. So a high pressure, again, spins clockwise, low pressure spins counterclockwise. At the dead center of both a high and a low, you don't have any wind at all. And I have a couple stories about accidentally sailing into the center of a low and being becalmed, but it's really rough and annoying because you've got waves coming from every direction. But anyway, the rotation of this Atlantic high, if you look on the south side of the high, you've got this easterly wind gradient. And over here off of Portugal, you get kind of northeasterly, northerlies. Off of Africa, you get northeasterlies. And you basically, that's the kind of the milk run, as they called it, sail south till the butter melts and turn right. So back in the day, Europeans, Columbus, those guys would sail from Portugal, parallel the coast of Africa in those northeasterly trades, and continue across the Atlantic in easterlies the whole way. Now, you can't do that in the summertime because of hurricanes. That's exactly, that trade wind belt is where hurricanes form in the summertime. But in the wintertime, you can follow those trades all the way across to the Caribbean. So that is why when you're down in Tortola, for example, where ICEBEAR is stuck in her own quarantine on the hard, it almost always blows out of the east in the Eastern Caribbean because they sit geographically right on the southern edge of that high pressure system and are directly in that trade wind belt. And weather that comes off the United States continent doesn't come that far south. You can see a cold front right here. That's a pretty strong cold front that goes down through the Bahamas. Those of you that have been to the Bahamas will know that winter in the Bahamas can be cold and gnarly, but these cold fronts very rarely make their way all the way down to the Caribbean because of the influence of this high kind of pushing everything around to the top. August, I feel like I'm talking really fast. Am I making sense?
You're absolutely making sense. I'm following so far. It's great.
All right, cool. So that's just one example of how when you zoom out, you can get an understanding of, okay, why does it always blow from the east in Tortola or in Grenada, where Sean is right now on ICEBEAR? It's because of this greater area of high pressure that sits there and creates this sort of funneling effect or this rotational effect that creates the trade winds. Now, talking about East Coast, where I grew up sailing on the Chesapeake, and when we're talking about, if August and I were talking about getting ready to go back across the Atlantic, as you get further north, actually, first of all, August, do you want to enlighten people and talk about what this band of latitude is called in the center of this high where there is no wind?
So the band of latitude in the you're talking about the horse latitudes.
I am indeed, yes. Yes.
Indeed. Yes.
You want to enlighten the history of why they're called the horse latitudes?
Yeah, so the horse latitudes is kind of a band where you generally don't have a lot of wind, because south of that you'll have the easterly trades, and north of that you'll generally have westerly winds that would propel people around the oceans. And you have a lot of these high pressure systems in the horse latitudes, where the old sailing ships would get stuck, and they would have to sort of kill their horses, because they would take up all the ship's resources when they were just wallowing around there in the calms without engines and with very limited supplies.
That's exactly right. So when we talk about trade winds and routes and stuff, as ships would come from Europe, they'd follow that bottom edge of that high pressure across to the Caribbean. But then to get back to Europe, if they took the direct route, they'd go straight through the center of that high. So that wasn't possible, especially in a square rig ship that was not able to go upwind. So typically you'd come north along the US continent and then work your way back around the top of that high. So if you look at the top of this high, now you've got southwesterly, westerly winds, but you're also right in this storm track here. So those of you that have heard about the Ark rally that goes from the Canary Islands to the Caribbean, a lot of those boats either continue around the world, get delivery crews to bring them back to Europe, or sometimes even get put on a ship, because it's much, much easier getting from Europe to the Caribbean than it is getting back. You have a lot more weather to deal with on the way back because you're right along this storm track. And the route back happens in the spring, early summer, and it's not unheard of to have a hurricane or a tropical storm that forms in May or June that can really mess with your planning on the way back. And we're going to talk about that specifically next week when we look at the departure window we would have had to get out of the Caribbean and get north. But anyway, again, trade routes, you'd go around the top of this high. Bermuda is right about there on your screen where my cursor is. Go from Bermuda over to the Azores, which are here. And if you stay north of this high far enough, you'll stay in these westerly winds, and the wind will be behind you most of the way, although you're going to get barreled down by the occasional low pressure system, which happened to us in 2017 going across the Atlantic. But you have to expect that. That's just part of the deal going back across the Atlantic. Okay, where are we? Let me look at my outline here for a second. Okay, so that was the trade winds. Continental weather, like I said, you tend to get low pressure systems that form either over the Great Lakes or over here off of Cape Hatteras or off of New England. And those low pressure systems tend to both follow, they kind of get squeezed north by this high pressure system, but they're also following the jet stream in the upper atmosphere. And you may have heard other meteorologists and weather routers talking about the 500 millibar charts. What the 500 millibar chart is, it's a picture of the upper atmosphere where the pressure, the barometric pressure, is consistently at 500 millibars. And that's about all I know about that, because I tend not to use them. And the reason I don't use them is that is a tool that meteorologists tend to use in order to create a chart that looks like this on my screen. And I would rather rely on a professional's opinion on what to do with those charts than my own opinion, not really knowing that much. And that comes back to the uncertainty thing we talked about this morning. So I tend to limit my weather input sources when I'm making a forecast to make a decision on the boat myself, because August, I don't know about you, but you can very easily get overwhelmed. And I think if you find a couple sources that you like and then maybe ask for a professional's opinion, and I'm going to get to that later, that's enough to make an informed decision and not overwhelming.
Yeah, absolutely. I agree. And you just spend so much time looking at all the different sources and just not get any sleep. So it can be a good idea to limit that a little bit for yourself, especially when you're offshore.
So August, I'm going to come back here and I'm going to stop sharing my screen. I'm going to put my video back on here, and I'm going to turn this over to you, because 2 years ago when we went up to Svalbard, I had to learn about the weather patterns up in your neck of the woods and how it affects the high Arctic and that kind of stuff. And I think you're much better suited to discuss that, because that's kind of where you've spent the last couple of years. So if you want to talk about how weather is developed in the northern Atlantic in your neck of the woods based on the big picture stuff, let's go for it.
Sure, absolutely. Yeah, first of all, you can kind of just see here real quick. I'm at 60 degrees north right now, and as you can see, this doesn't look like 60 degrees north anywhere else on the planet. This is I'm at the latitude of Siberia, Greenland, a lot of really frozen, icy places, and you can also actually see that I'm having a really nice day here in Norway. Just a testament to that high pressure system that you pointed out just over the west coast of Norway, Andy.
Yeah, I should mention all these charts I bring up this is real time. This is actually happening now.
Yeah, so that's cool. But the reason why this is so green and nice here is mostly because of the Gulf Stream. And maybe if I try to share my screen here for a second, I can.
I'll turn my video off here.
Let's see here. There we go. Okay. And then, okay. So do you see this map now?
Yep, I got it. You're good.
Awesome.
You're good.
Now, so you can see I'm all the way up here, and I've been doing a lot of sailing up here in the north of Norway, and both you and me, Andy, this is where we met. Oh, right by this heart, actually.
Where we first fell in love.
That's our first meet up there, and we went sailing, in open waters all the way up to 80 degrees north here, and that is a little weird. And the reason that we're able to do that is because of the Gulf Stream. That is, it comes out, it sort of connects to all the other great ocean currents in the world, but it comes up here along the northern coast of South America, going westwards, driven by this by the Azores high that's sort of churning, and the trade winds churning around this way. And the current goes into the Gulf of Mexico here. The water gets really warmed up, it gets really hot, and then it starts coming up the east coast of the U.S. up here, sort of passing between the east coast of the U.S. and Bermuda. And it's one of the challenges of sailing that route, is that the current's really focused and really strong here. And then it continues flowing up here past northern Europe here, and sort of basically acts as the heat pump for all of Western Europe, bringing in that warmth, and then also all the way up to Spitsbergen and to Svalbard, keeping this area ice free most of the year. Right now, you can still sail from mainland Norway to the south of Spitsbergen, even in the wintertime, actually.
Well, I was going to say, August, I mean, you used to run charters up in the very top of Norway out of Tromsø, specifically in the winter to do whale watching stuff.
Yeah, that's right. It's up here in this area here. It's around 70, 71 degrees north. We would go there in the middle of the winter for the only reason we would do that would be because of the massive amounts of whales up here, and the northern lights. But it was, yes, very cold and very dark, but still very, very beautiful. But yeah, the reason we can do that is because of this, because of the Gulf Stream, and also what keeps the northwestern Europe as warm and as wet as it usually is because of the Gulf Stream coming up here, and then the high pressure system that is the Azores high is located around this area in the wintertime, and it's churning this way. And then we usually get a low pressure system up here, sort of around Iceland, southwest of Iceland, and the two of those, because that is again low pressure system going counterclockwise. So the two of them are sort of acting like this pump, or this kind of gyre that's just pulling in all of this sort of warm and moist air from the North Atlantic, and sort of just
the low and the high together work sort of like gears, where they meet in the middle and they kind of create a funnel that shoots all that warm air and warm water straight towards the west coast of Norway.
Exactly. So that's why we usually get westerly winds here, especially this effect is more strong in the winter. So especially in the in the winter we get a lot of westerlies, a lot of precipitation, and
further,
not.
in your part of in your neck of the woods in Bergen, and then where I am, I'm over here in Stockholm, just outside of Stockholm. There tends to be a high pressure system over the Baltic that tends to block all the storms that come into the west coast of Norway. So where it's blowing like crazy and cold and snowing or raining where you live, it tends to not, we don't get that weather in Sweden at all. It tends to go straight up, shoot straight up the coast of Norway. If occasionally we get the odd low pressure that comes across southern Sweden, but it's much more common that they scoot off along the coast of Norway because of that blocking high that's kind of over the Baltic.
That's right. That's right. Yeah. So and you can see here's kind of Norway acting like a shield almost, protecting our Sötabro in Sweden from all the nasty weather. And what's also happening here specifically, if we go sort of into local stuff, is that all these strong westerly winds with all that moisture in the air is coming in from, and because of the high mountains in Norway, all that air is pushed upwards into the atmosphere, where it's get cooled, and the colder air is not able to hold the moisture so well. So it all rains down here or snows on the west coast of Norway, while everyone in Oslo are sitting snug and dry.
Hey, zoom in,
so yeah.
zoom in on your, zoom in on the map on your island.
Oh yeah, sure. Here we go. That's, oh, it has a little house on it. This is where I am. Let's see, right there.
August Island.
This house, August Island. This is the bay out here. This is my boats right here. And
oh
yeah,
man, look at that. There's a little bit of lag. We can see it. That's so cool. That's so cool. And back in the day, I remember you told me on the podcast, there was, when you grew up, there was no road to your island. You took a boat to school every day as a kid.
Yeah, we didn't have this road that goes across the island, was not there anymore, so we generally took a boat over to the little sort of local shop harbor thing over here. So,
that's so cool.
Yeah,
cool.
Okay, I'll hang on. I'll
put our videos back on and stop your screen share.
I'll stop my screen share. There we go.
So guys, I just had a quick look at the question. Some of these questions you guys have asked, we're going to address in the next section. So before I take any of them specifically, like the first one here, the most popular, do we have any suggestions for weather routing or grid viewing apps? Yes. So stand by on that. We're going to get to that. Excuse me. Okay. The next thing I want to talk about, this actually pertains to that question. Ryan, if you want to click start answering, I might as well take this question now because it's going to be relevant in this section. So that the way this works, guys, if you watch the replay, if we hit start answering now, when you watch the replay of the video, you can click on the question and it'll jump straight to the video where that question was answered. So Ryan, are you there? Can you hear me?
Yep. Which question are you going to answer?
The very first one. Do you have any suggestions for weather routing or grid viewing apps? I'm kind of going to answer that. But you can click it now.
Fire away.
What I want to make first of all is the difference between forecasting and routing. And Ryan, I want you to bring up Emma on the screen because I'm going to use her as an audience proxy and ask some questions to kind of lead us along the path here. So if you can bring up Emma, that would be super.
Emma is connecting.
Hey guys.
All right. What's up, Emma? How you doing?
Good.
Hey, Emma. Nice
so,
shirt.
Emma, you're at us from Colorado, right?
Sure am. It snowed like 2 feet here yesterday.
That's crazy. Wow. All right, cool. So routing versus forecasting. Do you know what the difference is?
Forecasting doesn't have anything to do with where you are or where you're going. I'm guessing.
Kind of, yeah. So forecasting, as I would say, forecasting is providing information about the weather, and routing is making decisions based on that information with where you want to go.
Yeah.
And there is a big difference, and people tend to confuse the two things. Typically, the way I like to do things on the boat, because I'm comfortable with interpreting a forecast, is I just want information. I want to be able to take the information and make my own decisions. So that would be forecasting. Routing is when you have somebody, let's say you've never been offshore before, and routing can be a very useful tool, but can also be very dangerous if you follow it blindly. So routing is where you have, say, a professional forecaster who is looking at the weather for you, knows what kind of boat you have, understands a good router will understand what your comfort level is and what you tend to want to avoid or not avoid, and they'll make decisions based on that. But they might be making decisions with more information that you have, and sometimes if you blindly follow a router, you're sort of giving up control. So did you guys, when you sailed south on your dad's boat in the fall, Emma, did you guys use a router?
Yeah, I was just going to bring that up. We actually, so I got a little free month with WRI, who we use at 59 North. And then my dad had an individual that he hired to do our weather routing. And so we kind of had a fun, like, compare the two. And we also had an app on the iPad that we could sort of scroll around. So we had a fun experience, like, comparing and contrasting all those. And sometimes we would just listen to the weather router and find ourselves in 10 more knots than he had said or that we really wanted to be in. And then, that was a good experience to say, okay, let's download a Grib file for the next 12 hours and see how this, stacks up with what we're looking at right now.
Yeah, exactly. So that's the key difference is, are you making a weather forecast or are you getting a routing recommendation? And those are two really different things. So I'm going to have all of us, Emma, you can stay on here, but just turn your video off. I'm going to do a screen share again to pop out and show you guys some apps. I can't show you everything that I like to use because a lot of it is on the iPad, which is back on the boat, which I can't get to right now. But I can show you what I use on the laptop. And then when we're on the boat, everything is done on the iPad. So let me share my screen and I'll turn my video off here and I'll show you a few tools that I like to use. Okay, so the first one is a program. I don't know if it's available for PC, but it definitely is for Mac. It's called Luck Grib. And Emma, can you still hear me? Are you still on there?
I can hear you.
I think Emma.
Andy.
Okay, bring Emma back up again. August, I'll ask you this just to keep it moving. Do you know what Grib stands for?
Ooh, gridded information in binary or
Correctamundo.
Oh,
Correctamundo.
yes.
So a Grib file is purely a file format. So it's usually .grb, and it's just a way of compressing a lot of information into a small file that then is interpreted by a Grib viewer to show a visualization of the weather model. And that's a key there in a minute. It's just like a PDF. Like if you have a PDF file, you need a PDF viewer to view it. Same sort of thing. So gridded information in binary. Now, when you're using a Grib viewer, you have to remember that there's a whole bunch of different Grib viewers, and they're usually all displaying the same data. The most common Grib model that's freely available is called the GFS, the Global Forecasting System. That's created by NOAA in the US. You've also probably heard of the European model. A popular app that I tend not to use only because I'm not familiar with it is Predict Wind. Predict Wind has its own proprietary model, and it also has what they call, I forget what it's called, but they take like 5 different models and put them together and give you like a, I don't know, there's a word I'm looking for, but anyway, shows you an ensemble, shows you what all those models averaged out together would look like. And again, this is another situation where you can get overwhelmed with information. I tend to use the GFS model and only the GFS model. It depends on seasons. Back to that uncertainty thing again, sometimes, August, it's useful to look at, if you're in an area like in the shoulder seasons with hurricanes and stuff, if you're in an area where the weather is really volatile, it pays sometimes to look at 2 different models side by side and see how over time, how they diverge. Because if both models over time tend to look the same, you can have a higher degree of certainty in the weather. If they diverge, and I've seen cases where, like, you'll see this on the Weather Channel, they'll talk about the European model with a hurricane track. And sometimes one model will not show anything at all, and sometimes another model will show an actual hurricane on it. So, like, it really depends on the season and how much volatility is in that. I also noticed that, you can probably comment on this, up in the Arctic, that uncertainty was so much higher because you don't have as many data inputs. Is that fair to say?
Yeah, absolutely. You don't have the amount of sort of data gathering points like land stations because it's so remote, and also just because you don't have any geostationary orbits possible, you don't have the same amount of satellite data up there. And in addition to that, you're dealing with like polar lows, which are very sort of unpredictable and very volatile. So it sort of confuses it even more.
I'm going to come back to that prediction part. But anyway, so this luck Grib is, again, it's just a Grib viewer. And I currently have, hang on, that's today's picture. This is a picture of the North Atlantic that I downloaded about an hour before we started this presentation. So if I jump from this picture, now let's bring this back to real time here. I think, yeah, where are we? Friday. Here's real time. So if oh, sorry, that was Tuesday. This is real time. There we go. So this is right now. This is the Grib models look at right now, and it's showing us the same area that we looked at on that synoptic chart earlier. But I want to show you how the two differ and what the differences are. So if you look here on the Grib viewer, you've got a high pressure center kind of southeast of Hatteras, kind of sitting right over Bermuda. You've got another high pressure center right in the middle of the Atlantic. You've got a low pressure center just to the left or to the west of Newfoundland. I didn't go all the way up to Greenland, but you've got a light area of low pressure here sort of sitting in the Bay of Biscay between Ireland and northern Spain. So that's what's going on in this picture. If I go back to the synoptic chart, visually at first glance, it looks very different. But if I look closer, I've got a high pressure in the middle of the Atlantic here. I've got this other high pressure southeast of Hatteras, just kind of like what the model said. There's this light area of low pressure here off of Bay of Biscay. So you got to remember, this is showing the same information, although the major difference, and this is a key point, remember this synoptic chart is created by a professional weather router. This Grib view is pure mathematical data. So what a Grib model is, it is a whole series of inputs that get put into an algorithm, and it spits out a future prediction, a forecast. So Gribs can be dangerous because if you're not understanding their limitations, like a meteorologist does, you can draw sort of unsafe conclusions from a Grib because it's not been interpreted by a human professional. And where that really gets tricky is in these areas of high volatility, especially when we talk about, I used to run the Caribbean 1500 cruising rally, and that was from the Chesapeake down to Tortola. And that was in the fall, right at the tail end of hurricane season and at the beginning of the winter weather season. In August, you and I just did that passage on each boat last fall. And that's really tricky. There's a lot of volatility in the weather, in the atmosphere at that time of year. And all these different models, and some like WRI, our forecasters, they'll probably have their own proprietary model, and they'll also have access to models that cost money. And now some Grib programs allow you to buy those models and look at these different models, but a weather forecaster will understand the pros and cons of each. So for example, the GFS model may be really good at tracking, I'm going to use hurricanes again as an example, but the GFS model may be really good at tracking the course of a hurricane, but the European model may be better at tracking the intensity of a hurricane. So a professional forecaster can look at all those different models and sort of create then a synoptic chart like this that takes into account all that different information. So that's a long-winded way of saying when you're looking at a Grib, remember that you're just looking at mathematical data that's never been interpreted. Also, different Grib viewers will show different things. One of the nice things about Luck Grib is that it actually shows the centers of the highs and the lows. You can interpret those centers by looking at where the ICEBEARs come together, but most Grib viewers don't actually put an H or an L on the chart. So this is a little bit of a nicer visualization. Okay, so what I'm looking at here, the color gradients represents wind speed. So the redder the color, the higher the wind speed. Bluer the color, the less wind speed. You can see the wind barbs, the arrows on there again. This is that trade wind belt that we talked about coming across the bottom of the Atlantic. And then you've got the isobars. If I hover my cursor anywhere over the screen here, in the top right of the screen, you see the key. That shows me at that particular spot what the wind speed is, what the sea level pressure is, what the surface wind is, if there's any rain. I can toggle in the bottom left here what gets overlaid and what gets prioritized. So if I look here, I'm highlighted on wind, rain, and pressure. If I just want to look at pressure, now all my map shows is the isobaric pressure bars. So I'm toggling on and off layers of data by using the side here. And all Grib viewers do that differently. There's rain. So that is just showing me where the predicted precipitation is going to be based on this particular model. If I look at rain overlaid with pressure, then I can kind of decide how does rain correlate with pressure. And this is the next part here, rain, wind, and pressure. And if I look at, let me look at rain, wind, and pressure. So this is an interesting view because what a Grib viewer does not show you, I'll go back to the default view for a second here. What a Grib viewer does not show you that a synoptic chart does is fronts. So you can see very clearly where the fronts are on the synoptic chart. And fronts are really important, especially cold fronts, because a lot of stuff is happening along that front. There's a lot of volatility in the atmosphere, and you have to understand that there's going to be strong wind shifts. What's happening with a cold front is you get dense cold air down at ground level that is advancing and pushing underneath warm, moist air that is in front of it. And that creates convection, just like August was saying the mountains do in Norway. Cold air going under warm air creates convection. You get air rising in the atmosphere. As it rises, as warm air rises, it cools and condenses, and that's what creates rain and thunderstorms and nasty weather like that. When you combine that with, say, over here off of Hatteras, with the extra warm water of the Gulf Stream, you can get some real crazy stuff that happens real quickly if you're not paying attention. And one of the classic mistakes people tend to make is departing from the Chesapeake to go either out to Bermuda or down to the Caribbean on a southwesterly wind. Southwesterly wind tends to indicate an approaching cold front. And as you get out into the Gulf Stream, if you get a frontal passage in the Gulf Stream, that can really get nasty really quickly with thunderstorms and a lot of convective activity because of that warm water. And that's hard to predict as well. So that's an area of uncertainty. So the way we always used to do it is wait till the front goes through, go out on the backside of it when the wind shifts to the northwest. And sometimes it's blowing really hard, like it was for us, August. We were going down the bay. It was blowing 25 to 30 knots. But the key was it was clear, stable weather as opposed to an approaching cold front. And that's a little bit of an aside there.
Yeah,
but,
and it was behind the beam, and so it was glorious sail down the bay.
It was perfect. Back to the Gribs. So on the synoptic charts, you can clearly see the fronts because Mr. Nolt or Mrs. Nolt drew them on there. And why he drew them on there is he was looking at a file like this, a data file like this, and interpreting where the fronts are based off of this. And that's what I'm going to show you guys now, how to make that interpretation. So if I go back, a better view to use here is rain and pressure. Oh, no, sorry, I'll do rain, wind, and pressure. So cold fronts tend to form off the front edge of a low pressure system. So if I look up here, I'm going to advance this a little bit to give you a clearer picture. There's a very clear low. This is now on Sunday. So this model is predicting a pretty strong low moving off of the U.S. North American continent, centered just south of Nova Scotia, out there by Sable Island. And you can very clearly see the rain. And let's advance this a little more to see if we can get a better picture here. Here we go. This is a perfect example. So that low now is east of Nova Scotia. You can see the rain, and the rain is going to be right along where the cold front is. So by using the precipitation layer in my Grib file, I can interpret where that cold front is. Now, this is Sunday's forecast. So this would be 48 hours from now. I'm predicting that there's going to be a cold front extending kind of from the edge of Newfoundland down towards Bermuda. You can also see another indication. If I look at just wind and pressure, I've turned the rain off. Look at right here. I'm going to zoom in a little bit. There is a very distinct wind shift. You've got southerly winds right here, and right next to it, you've got westerly winds. That is your cold front right there. And if I put the rain back on, that's right along the center of this band of rain. So by looking at a couple different layers in my Grib, I can interpret that there's going to be a cold front there. What this is not showing me is a lot of times as that front passes overhead, you get a violent wind shift. And this is only showing 25 knots right here behind the front, but it's showing 30 to 40 knots in front of it. As that wind shifts through, you might see 50 or 60 knots very briefly at the leading edge of the front. And that's what the Grib is not telling you. And that's where you can get into a lot of trouble if you're not ready for that frontal passage. Now, if I zoom out again, like I said, this is 48 hours from now. If I go back to my synoptic chart and look at the 48-hour prediction, this is a little bit behind. Let's look one day ahead. There we go. There's Newfoundland. Here's that cold front wrapped down right off that low. So what I've just done there is showed you what a meteorologist would do looking at not just one Grib model, but several to make an interpretation based on what they understand about the data to then draw out what this actually looks like. And if you look here, this is showing a hell of a lot more wind than the Grib. That's 45 knots right there. That triangle's 50. If I go back to the Grib at the same time, I'm showing, if you look in the top right screen, well, there's 50 there. Yeah, so maybe it's similar, but it looks scarier on the synoptic chart than it looks on the Grib file. So this is what I tend to do before leaving on a passage is I'll get the Grib model out, I'll get the synoptic charts out, I'll look at how they diverge, especially over time. And I'm going to probably trust the meteorologist's forecast more than the Grib forecast the further out from the date of the forecast, if that makes sense. August, while I gather my thoughts, do you have anything to add to that or comments?
I will just comment on the sort of
Video back on.
unpredictability of the Grib files. Like another mistake that I made in my.
You can put your video. You can put your video back on, August.
Okay, cool. Yeah, just when I was sailing around in my Baltic 10 years ago and sort of learning the ropes here, I trusted too much in the Gribs into, like I would sort of, because we didn't have any way to download weather forecast offshore, so we would just get as much forecast as we could before we left and then say that was a 10-day passage, then that was what we had. And whereas a meteorologist would throw his hands in the air if you asked him what the weather was going to be like in 10 days, the Gribs doesn't really do that. They sort of just, yeah, like you can download a Grib and get a 10-day forecast, but like the last half of that's going to be absolutely worthless. So
that's a really good point, because the synoptic charts I was showing, they only go out 4 days. You cannot find a synoptic chart on the Ocean Prediction Center longer than 96 hours in the future. And that's for good reason, because they don't freaking know. It's like,
exactly.
I don't know.
Yeah, it's pure.
You might as well pick a number out. Yeah.
Yeah. So if you line up two different Grib models and just scroll out to 10 days and just see it's like two different worlds. It's just crazy.
Well, one fun thing to do is to take a Grib model, download a Grib file today that maybe goes for 10 days, and then 7 days from now, download a new one, but save the old one, and then take the old one out 7 days and lay it over what the one you downloaded at the 7-day mark, and see how much different they are. And I guarantee you, especially this time of year in the springtime now, there's a ton of volatility in the weather because we're transitioning between summer and winter pattern. They're not going to be the same. And if they are, it's just pure luck.
Yep, absolutely.
Okay, so that's kind of the couple of the tools I use. So just to summarize, I use LuckGrib on the computer. I use a really awesome program that I wish I could show you on here on the iPad called Weather 4D. Excuse me. Weather 4D is a paid-for program, but it's really cool. And what it does, it allows you to input your boat's performance parameters, which is called a polar diagram, and then you can actually overlay your routes right on there and do kind of amateur weather routing. I spent a whole podcast. So those of you that listen to my How I Think About Sailing podcast, you can go back in the archive. There's one where I did talking about the iPad software. But Weather 4D is the one that we use on the iPad. It's basically the same interface as LuckGrib, but it allows you to plug in routes and do some pretty neat routing stuff in there. And we've used that for pretty much since we started the business, the last kind of 5 years. Okay, so the other tools links are ocean.weather.gov. That's where I got the synoptic charts from. And then coming up into the summer hurricane season, the National Hurricane Center, that's nhc.noaa.gov. I'm not going to show you that because there's nothing on the site right now because there's no activity, but that's the best place to track tropical weather. You'll have heard of passageweather.com before. That's basically just an online Grib viewer. It's pretty low res. A lot of people use it. I tend to look at it occasionally, but it's showing the same detail. It's showing the same models as any other Grib viewer. I tend to, August, I think we've talked about this before. You got to get, people have a tendency to get complacent with, there's a big difference between resolution and accuracy. So you can have a really high res chart of a model, but it's only as accurate as the model data within it. And the same thing, it's a way you compare it to like electronic charts. You can zoom way the hell in on modern electronic charts and it looks like it's like super high res, but it's only as accurate as the underlying data that has created that chart in the first place. And that's where people tend to have trouble with navigation stuff. It's kind of a similar thing.
Yeah, because that data, I think it was Tom Cunliffe who said that data that shows up on your brand new digital chart might be a measurement from a drunk midshipman with a lead line 200 years ago. So,
yeah, exactly.
Yeah, you shouldn't put too much trust in that stuff. So,
and I'm gonna say one last thing here before we go to the next section. A note on heavy weather. Heavy weather is extremely subjective. That situation you described at the beginning of this talk, August, I mean, that was pretty gnarly, 40 knots, but it was probably felt a lot gnarlier then than it would feel to you now after having the last, 12, 15 years of experience under your belt.
Absolutely. Yeah.
And so, heavy weather for somebody that's never left the Chesapeake going to Bermuda could be 25 knots. 25 knots and 6-foot seas is a lot different than what the conditions are like on the bay or wherever else. So, heavy weather is extremely subjective. And that's why, just to toot our own horns here for a second, it's really good to go offshore with somebody that's done it before, because just the attitude of whoever's in charge, how they handle it. You saw the video of us in the Atlantic. There wasn't really any drama there. And we knew there was no point in trying to get that mainsail down because it wasn't going to happen. I didn't want people on deck because it was unsafe to be on deck in that situation. We just had to ride it out. And those experiences, you can have an experience as a newcomer in charge of your own boat in 25, 30 knots, and it can be horrible. You go out with somebody like us and you can be in 45, 50 knots, and it can be a very pleasant experience because you're just handling it differently. Does that make sense?
That makes a lot of sense. Absolutely. And I'm sure I would look at that situation a whole lot different today. I would never have gone out at all in the first place, but yeah, you're absolutely right. Experience has a lot to do with it, and also, of course, the size and especially the design of the boat that you're on has a lot to do with it. I've seen a lot of heavy weather in a lot of different boats, and yeah, there's some boats do it well and others do not. So and ours do them very well.
And then what you have behind me is some serious heavy weather in the Southern Ocean. That's about as real as it gets. So that was from the Whitbread race from 1985, 86. That is, that waves don't show up in photos. And when they look like that in a photo, man, it's a big one.
Yeah, that's hardcore.
So one more section to go here. I'm going to speed through this a little bit because I want to take some questions, and we're already at the, what are we, an hour and 10 minutes. I just want to talk briefly about departure weather. And this is what we're going to talk about specifically next week, August, when we look at that BVI to Bermuda passage, is what are we actually looking for when we're making decisions? And a couple just kind of bullet points on that. I've made some notes here. When do we not go? When do we bail? And that's also subjective. But when I tend to look at a departure window, I'll use the Caribbean 1500 again as an example. There's a lot of times where we'll leave when it's, Jeremy at WRI sitting in his office, he always tells me conditions are far from ideal. And it's like, all right, I get it, but we're not going to get an ideal window. So what is it going to be? And I tend to like to leave when you're in a pattern where you know it's not going to get any worse. So, for example, we left the Chesapeake. We knew it was going to be really windy and it was really cold. But if you recall, by the time we got out into the ocean approaching Hatteras, we were motoring. It was flat calm. And we got across the Gulf Stream in a relative calm before we picked up the next cold front and got to sail then basically from Bermuda south. So as opposed to leaving the Chesapeake ahead of a cold front, you know that you're going to have some gnarly weather passing over you as you go and in the beginning of the trip. And I would much rather motor for the first 2 days and let everybody get their sea legs than to go offshore straight into a heavy weather situation where you're going to just scare everybody away, especially if you've got new crew on the boat. So when I'm making my departure decisions, ultimately it's about, are we in a stable weather pattern and how certain am I about it? Another example, we left Bermuda last year on both boats to go back to Annapolis, and there was a tropical storm starting to form on the Gribs, on the models, like 3 days after we were set to leave. And again, it didn't exist, but it was in the models. So Paul Exner was the skipper on ICEBEAR, then we both decided, like, let's get the hell out of here right now because we need to get 3 days away from this if it actually happens. And sure enough, it did. It was the season's first tropical storm. It stayed south, but had we sat in Bermuda, we would have had to sit for probably another week because that tropical storm formed right over Bermuda and sat there. So there's always a little bit of chance in here. And the last thing I'll say about that is, if you're not prepared to encounter whatever you're going to get out there, don't go. Or if there's a risk of overwhelming weather, if there's any chance of a hurricane, don't freaking go. And then when to bail, I mentioned you and we were coming down on ICEBEAR from Lunenburg to Annapolis, and we ducked into Newport. If you just want to briefly tell why we did that at the time, basically because we had the opportunity to. If you want to just describe that situation, August.
Yeah, sure. We were sailing down there from Lunenburg, aiming for Annapolis, and it was a nice, sweet sail. But we saw this really gnarly cold front coming up on the forecast that was coming off the continent there, and again, like you said, Andy, the cold front is going to push up all that hot and humid air and causing a lot of rain, a lot of strong winds, wind shifts, and even thunderstorms as well.
Lightning was the big issue for that one.
Lightning as well. Yes.
They were calling for, like, I think the beauty of it was we were seeing that this front was not just on the model, it was actually happening, and it was moving over Delaware and New Jersey. And we had gotten some local reports from my dad, who I was texting with, who said there was like 70 knot wind gusts over New Jersey. And the reason we stopped was purely because we could. We were sort of sailing coastwise, and it's like, well, I can be in Newport eating dinner at Liz's apartment in 12 hours, or we can ride out this lightning thunderstorms out here. And sometimes if you're going to Bermuda, you don't have a choice because there's nowhere to stop. But I almost always take the conservative decision when I have the option. In that case, we did, and it sucked because it was our last trip of that season, and it was the first time in the history of our business that we got delayed by a day, and one or two of the crew had to leave in Newport. But sitting there in Liz's apartment while it was blowing like crazy and thundering and lightning in the harbor, I think we were both pretty happy.
That was really great, and like I think like good seamanship is about that. It's about being smart and getting out of avoiding trouble in the first place, and not being like standing off a storm, Captain Barbossa style offshore. So the best way to win a fight is just to run away. That's my my philosophy.
I'm with you on that. So, all right. I want to open up to some Q&A. I see we have about 17 questions in the queue here. I'm done talking about new information, but I'll give you a quick preview to next week. If you guys enjoyed this, we're going to go into more specific detail looking at the route from BVI to Bermuda next week. And we're actually going to have Jeremy Davis, our professional router from WRI, joining us on the live stream. We're going to simulate what it would be like. Jeremy's going to talk to us as if we were sitting on the boats in Tortola getting ready to leave. And we're going to look at how do you translate a text forecast that a professional router would send you, because that's an art in and of itself. So today will be a good primer for that. We're going to do some questions in a minute. Don't forget, if you think this was valuable, fire us some quarantine beer money. We would most appreciate it. And just a reminder that all the links and stuff that I mentioned are going to be on the show notes. I think Ryan has been sending them some links in the chat. But we're going to open it up some questions. Those of you that have other places to go, it's been nice having you. If you want to stick around, I think we'll do some questions. So, Ryan, do you want to turn your mic on? Can you hear us?
Loud and clear.
Hey, how's it
Ryan.
going? Cool. All right, let's see here. Let's go to the questions. I'm opening this up. I'll have you do the button thing here, but let's take a look here. I don't know, Ryan, have you seen anything that popped? I haven't looked at these yet. Have you seen anything that caught your attention right off the bat?
Rory had a question about algorithmic routing versus human routing.
Okay, that's a good question. Yeah, Rory, how's it going, man? Rory has actually sailed with us, raced with us a bunch. So, Ryan, if you want to start answering that question, what Rory means by that is the routing that can be done like on our iPad software, where you put in the numbers and the computer does it for you, versus human routing, where you're looking at it and making your own decisions. So, what I tend to do is I'll do a combination of both. Before I let the computer do the routing, I will let the weather play out, and I will look at, do I want to stay on the straight line from A to B, or does it look like there's any reason for me to go one way or the other? And you got to remember, there's a big difference in routing when you're talking cruising or racing. When you're racing, you want to get there as quickly as possible. And sometimes that means adding distance to stay in a better breeze, but the goal is to get there as fast as possible. When you're cruising, you have the luxury. I mean, you still want to minimize time at sea as far as heavy weather and stuff like that, but presumably those of us that are out there cruising enjoy being at sea, and there's no reason to fight your way upwind if by adding a day or two to a passage, you can go around the weather or use the weather to your advantage to make the passage more comfortable. So when I talk about routing, I'm talking about cruising routing and making it more comfortable. So I'm going to use an example from departing Iceland for this. We were going from Iceland down to Ireland, and it was a really tricky weather window. And it was either sit in place for like a week and take the uncertainty of we didn't know what the weather was going to be a week later, or we leave now, motor for the first 3 days in calm, and then try to get between these two low pressure systems. And we ended up, I'm going to try to pull up, I'll save that for later. I'll put it in a link. But basically what we did, we sailed like a zigzag course because I didn't want to go upwind. The biggest thing with routing for me is avoid going close hauled. Going close hauled sucks, even in nice weather. 15 knots of true wind. When you're on ICEBEAR going 8 knots, you've got 22 knots apparent coming over the boat. That's 2 reefs in the main, small jib, and water coming across the deck. And it's only 15 knots true. 20 knots true is super gnarly, and pretty much anything over 20, 25 knots, you're not really making any progress. You might as well just heave to. So I always look at, all right, how can I play the angles? If I can make close hauled, say 40 apparent, if I can make that 60 apparent, that's night and day. If I can keep the wind behind me, that's even better. So I will always go out of my way to stay in nice kind of angles as opposed to going upwind. Where this comes into play with computer versus human routing is the computer is always trying to get you there as fast as possible. So sometimes you have to override the computer's route and say, all right, I'm not going to do that, especially upwind. The computer always overestimates how tight you can sail to the wind. It's just never realistic. So I'll look at the weather myself. I'll decide, okay, this is how I want to go. I'll run the computer simulation and I'll see, does my idea jibe with what the computer said, or is the computer are they way different? If they're very different, then I'll second guess myself and go back and look at it more closely. Same thing with a professional router. If Jeremy calls us up and says, I think you should do this, and I had a completely different idea, then I'll get on the phone with him and we'll have a conversation about why we had different ideas about things. So typically I do a hybrid approach, Rory, if that makes sense. Cool. Good question. Any other ones, Ryan?
Yeah, there's a question about when you're looking at a forecast, do you look at the gust or the average wind speed, or do you look at both? And how do you kind of think about the two of those?
All right, cool. Yeah, start answering that one. Good one. So how do you look at gust, wind speed, average, whatever? Again, it depends on what I'm looking at. I tend to sort of look at both. I almost sometimes will assume whatever the gust data says in a Grib, that's actually going to be what the average wind speed is. I tend to always overestimate it, because if you overestimate it, then you can't really get yourself in trouble. August, you're sitting there shaking your head.
Yeah, yeah, that's true. I remember back when I was sailing on Gribs exclusively, I would put in like the Grib VAT. So I would look at the Gribs and I would add 25%, and that was what I would estimate the wind would be.
That's awesome. Yeah, and that's like I was saying before, when you're looking at a Grib and interpreting where a cold front is, there's almost always going to be extra wind around those frontal passages. So I kind of just mentally add that in there myself. But if you always use the gust, the thing is too, out in the open ocean, I get annoyed when people. We used to do this on the rallies. WRI would forecast for the rallies, and they'd send a text forecast out. They'd give you a synopsis of the big picture, and then they'd give you like a 3-day forecast based on what area of the ocean you were in. And people would always get bent out of shape when, there's 10 more knots of wind, and they said, there's 10 less knots of wind. It's like, that's pretty damn good. If they got the direction accurate and they got it within 5-10 knots, like what more do you expect? I mean, you're at sea on a boat in the ocean. You can't. It's not an exact science, and they're doing this from their office in Albany in WRI's case, and it's just I don't like that. You can't expect weather guys to know the future, but and that's why I said if you look at the big picture, you'll understand. Okay, why am I getting a westerly wind right now? Is it because there's a low pressure approaching, or is it because there's a high pressure moving off? If you know the big picture, you'll know what to expect based on the trends of the larger weather patterns, if that makes sense.
Yeah, that makes a lot of sense.
Cool. Next question,
right.
Ryan.
Yeah, there's another question here from Joe Darty. Can you explain the relationship between low pressure systems and cold fronts and how they impact each other?
Yes, that's a good one. That's going to be a longer one. I'm going to share my screen again. So August, if you want to turn your video off for a second.
Yep, sure.
So Ryan, I'm going to need you to repeat that question in a second. Let me turn my video off. Okay. What was the question again, Ryan?
The question is, can you explain the relationship between low pressure systems and cold fronts?
Okay, yes. So I'm going to make this a roundabout explanation. If we go back to the synoptic chart, not all low pressure systems have fronts associated with them, and you can have a cold front that doesn't have a low pressure associated with it. A cold front, strictly speaking, is a boundary between a cold air mass and a warm air mass. And sometimes they can just be stationary and sitting there. You can see on the synoptic chart, there's a stationary cold front over the top of Newfoundland right here that is not attached to any low pressure system. That's just a boundary between cold air north of it and warm air to the south of it. Interestingly enough, I'll ask a question back to you, Ryan, since you asked me this. Do you know why is a tropical system, like a tropical storm or a hurricane, what makes it tropical? As opposed to, like, you can get a winter low pressure system, sometimes we call them nor'easters, that are just as strong as a hurricane or tropical storm, but they're not classified as such. Do you know the answer to that, Ryan?
I do not.
August, do you know?
I guess like a tropical system develops in the tropics. That
would be wrong. That would be a good guess. That would be wrong, because lately, and you've seen this, where you get these tropical storms and hurricanes that actually form outside the tropics. As an aside, the tropics are specifically defined by 23.5 north and 23.5 south. I keep ripping the headphones off my ears here. Give me a second. But no, August, it's actually not because they form in the tropics. It is because a tropical system does not have fronts associated with it. So that's the only difference. And I'm going to ask Jeremy Davis, a non-tropical or a subtropical system has fronts associated with it. So it's a rotational storm. If I go back to the Grib viewer, this low pressure here is a rotational storm that has a warm front and a cold front associated with it. A tropical system can evolve into a subtropical system. So like August, you're on the west coast of Norway. You don't actually get hurricanes that make landfall in Norway, but you get the remnants of what was a hurricane that as it traversed across the Atlantic, it evolved into a subtropical system, which means it tends to widen out and takes on frontal boundaries as it makes its way across the Atlantic. So that is the difference between a tropical and a subtropical system. And give me 1 second, because August, you got to keep talking for a second. I got to untangle my headphones. Hang on.
Cool. Yeah. Like another sort of thing that you also often see, especially in the US with these the cold fronts and the low pressure systems, is that it is the low pressure system that will sort of drive that cold front around. Because often the warm fronts and the cold fronts will sort of act like the hands on a watch, where like the center of the low will be like the center of the watch, and that'll sort of drive it around. Was that any?
The hands of the watch are going backwards as they rotate.
Yes, counterclockwise. That's true.
Good, I never heard that. That's a good analogy.
Thank you.
I think
came up with it.
that's perfect. I think we probably answered that one. I hope that's the relationship between cold fronts and low pressure systems. So Ryan, I'm going to stop sharing my screen. Let's put our videos back on. Let's take another one.
Oh, yeah.
Okay, here's a more simple one. Any reading recommendations for a weather novice?
Oh, man. I actually don't have any weather books off the top of my head. Do you, August?
Oh, I do have one. Oh, what's it? Hang on. I'll do a very quick search here.
I see that Mark suggested Mariner's Weather by William Gord. Have you guys ever read that book?
I've heard that. Yeah, I've heard that one. Yeah. Maybe throw the link in for that one, Ryan.
Yeah. What was that? The one, I think the only book I read about this was Modern Marine Weather by David Birch.
Okay. Mm-hmm.
I've read some more. He's a really great guy. I'm not actually sure I finished it. It is pretty.
What we didn't talk about today is like actually standing on the boat, looking at the clouds in the sky and interpreting stuff like that. And that definitely is part of this. And it, we've focused on all the tech and stuff, and it's classic meteorologist stuff. What's the weather doing? We'll look out the window. But that's not really what I wanted to talk about today, but that's clearly part of this for further study. Cool. How about another one? Brian, you still there?
I'm here. Yeah. So Emma wants to know, how will 59 North do weather forecasting in the OGR? Have you thought about that yet?
The anti-tech OGR. That is a great question. I think less up to us and more up to the organizers, but I think August is gonna. There you go, a barometer.
We could use this thing, I think.
That's how we're going to do the weather forecasting. That remains to be seen. Good question. I actually see one here, Ryan, I want to take from Ben Day about downwind. If you want to start, click the button to start that one.
Yeah, let me just find it.
It's the third one down, it looks like.
About reefing?
Yeah.
All right, fire away.
This is a really good one. So I'll read the question. This is from Ben Day. He says, you've spoken before about being able to reef downwind. Not all boats are set up this way. Reef early for sure, but if didn't and you can turn into the wind, do you just run with it till it's over? So if your boat's not set up to reef downwind, get it set up to reef downwind before you go offshore, because you cannot turn up into the wind. You saw from that video, if I had turned the boat into the wind, that mainsail would have beaten itself to shreds. We would have been beam on to the seas. It would have been a disaster. Now, in most cases, we can reef both boats downwind unless it's blowing 50 knots like it was then. And a lot of the keys to that actually have been removed by modern boat design. When you have swept back spreaders, that limits your ability to ease your mainsail out because the sail gets hung up in the spreaders and makes it hard to lower that sail. Likewise, roller reefing booms, roller reefing in-mast furling, all those systems do not work very well when you're going downwind. So that's why I keep preaching, keep things simple. With a mainsail that hoists with slab reefing on a track on the mast, you can always fight it down. You got to be careful when you do reef downwind. You got the sail eased all the way out. It does get hung up in the rigging, but you just got to watch it and be careful. And you can pull it down. Sometimes you have to kind of bring the boat up a little bit onto the wind instead, not onto the wind, but if you're going dead downwind, you might bring it up to like not quite a beam reach, but just enough to get the mainsail to luff a little bit. But you got to be really careful doing that because you're increasing the apparent wind and you're knocking the boat around. And you can get fooled into reefing late when you're going downwind because you don't quite notice the wind building, because as the wind builds, the boat's going faster. So the apparent wind really is the same. I have a cool video from the drone of us. We had the spinnaker up going across the Atlantic, and it was probably blowing 22 knots true by the time we said, "Oh shit, we got to get this spinnaker down." And it came down fine. It was good, but it was pretty gnarly, and we probably pushed it a little too much there. But the answer to that is, if you can't reef your boat downwind, figure out how to, because you need to.
Some boats with that has like in-mast furling that I'm not a fan of in general might be able to reef downwind only on one tack because of the way it spins inside the mast. So if you have that system, you might actually have to sort of premeditate your reefing a bit more and maybe sort of set up your tacking before you do that.
So here's a good quick one, specific to weather, Ryan. Again, it's the third one down from Jim P. Says, define a ridge and a trough. If you want to just click that one.
Yep.
So, all right. So a ridge and a trough. If you have a high pressure system and a low pressure system, if those are like rotational areas of pressure, a ridge and a trough is simply an area of low pressure that hasn't formed into a rotational system. Likewise, with a ridge, it's an area of high pressure that is just a gradient that's not actually rotating. So that's the difference between a ridge and a trough. Ridge meaning high, trough meaning low, but they're not actually rotational. So sometimes you can get weather that forms in a trough. Sometimes low pressure systems develop in a trough, but it's not actually rotating yet, if that makes sense. Did I answer that right, August? You're shaking your head.
Oh, I'm nodding. I'm
good.
Appreciating the info.
Let's do. All right, that was 90 minutes. Let's do. Let me look at this one more time. Okay, here's a good one. This will be our last question. This is from Adam. Ryan, again, it's the third one down. What would be appropriate options for weather data if you're not able to download Grib files? I actually have a story about this. So first time, this is, what would be appropriate options to get data if you're not able to download Grib files? The key for us is being able to communicate. So the first time we went across the Atlantic on Arcturus, Mia, myself, and my friend Clint, we didn't have an iPad. We didn't have a computer. We were using paper charts and a handheld GPS, but we did have a sat phone. So what we did was my dad at home would pull up the Gribs, and every 3 days or so, I'd pick up the sat phone and I'd call him, and he would just describe what was happening in the Grib. He would say, okay, here's what's happening now. You've got a high pressure centered here. You've got a low pressure centered here. Tomorrow, the low is going to be here. And we would physically plot on paper the centers of those lows and highs as we were going across the Atlantic and sort of create our own little sketch on pencil and paper of what the big picture weather was doing. And again, it was very low resolution prediction based on that. But if we knew where the systems were going, we knew at least what wind direction and relative wind intensity we'd have. We didn't know exactly what the wind speed would be, but we knew whether it was trending up, trending down, and which direction it was going to come from. Now that was, we needed a sat connection, or at least a voice connection for that. If you have no connection to the outside world whatsoever, then you're looking at the clouds at that point. But that was a way where we didn't have a computer or anything. We could call somebody who were able to describe that, and that requires a little bit of a knowledge of being able to understand a description. But that's what we did going across the Atlantic, and that was pretty fun. Mark is saying, he said his cheap weather was through the DeLorme InReach, and you can get a text forecast back from that. So, and I've seen people do that before on those small but it's still satellite based system. All right, I think. August, do you want to keep hanging out? I think I'm ready to sign off. It's been an hour and a half. Those were some great questions, guys. I hope you enjoyed this. I'm very happy to say that it doesn't look like anybody left the chat. We still have the same amount of people that we started with, so I guess we're doing something right here. Yeah, that's really cool. Yeah, even at 90 minutes, that's been awesome. So this is a blast. So cool. I'm not sure how to end this. Thanks, guys. I guess we're going to do this again next week. I should say we're going to have, there you go. Thanks, Ryan, for popping the contribute button up there. I forgot to plug at the top. Ben, Liz, and Emma the 359 North, the newcomers and the youngest people that we have working for us, they're going to host what we're calling the Young Stream on Tuesday. So that's Tuesday, April 21st. They're going to talk about how they got into the sailing industry and how they started working with 59 North. So come back for that one. I forget what time it's at, but it's on the website, 59-north.com/live. And that's going to apply to anybody of any age, because if you want to break into the sailing industry, they're going to talk about how they did it. So that's going to be hosted by Ben and with Liz and Emma. I'll be on at the very beginning to introduce those guys. Otherwise, August and I will be back next Friday for more weather specifics. And we have a lot more fun stuff in the works with a couple people that you will have recognized from the podcast coming up. So thanks for joining us again. And August, any last words?
I'll just say this has been really fun, and I'm so thrilled that so many people showed up. And if you guys who've been watching have any, like, we're just starting this up, if you guys have any feedback or recommendations, just please reach out and let us know if there's anything we can do better. And yeah, no, I'm loving this. This is great. So I'm looking forward to the next one.
Awesome. Cool. Thanks for moderating, Ryan. I think you're in control of this now. You can sign us off, but thanks guys. And as usual, hold fast.
Yarr.
Yarr.